In the following tutorial, we will be testing the operating conditions of a simple machine. This is a simulation of the vertical component of a two-axis machine. These types of mechanisms are used extensively in machines like 3D printers and CNC machines. To examine the stresses that occur on the machine, we will simulate a 10 kg mass 0.1 meters away from the machine, as if it were attached to the front mounting plate. This tutorial will help us understand the structural stresses that the machine undergoes, and will serve as an introduction to the ANSYS AIM software. It will also help increase our understanding of solid mechanics and finite element analysis. We will determine whether or not the machine will withstand the stresses of these conditions. The machine is made mostly of aluminum, which has a Young's modulus of 7.1 times 10 to the 10th pascals, and a Poisson's ratio of 0.33. The linear guides and rails are made from steel, which has a Young's modulus of 2 times 10 to the 11th pascals, and a Poisson's ratio of 0.3. The linear guides will undergo plastic deformation if they're put under a force of 4.2 times 10 to the 8th pascals or greater. The forces acting on the machine are caused by gravity and a 9.81 Newton meter moment. This moment is an approximation of what would occur if a 10 kg mass was mounted to the front plate and its center of mass was 0.1 meters away from the plate. It is assumed that there will be no other external forces and that the machine is sitting on a flat horizontal surface. To start the analysis, select Structural Template. If you'd like to start from scratch, select Define New Geometry. If you have a file you'd like to use, select Import Existing Geometry. After you have selected what you want, click on Create Simulation Process. If you have selected Import Existing Geometry, you can now select your desired file. Once the simulation process has been generated, go over to the Geometry tab. If you'd like to edit the geometry in ANSYS, click on the Edit Geometry button. This will bring you to the workbench where you can edit the geometry of your model. When you're done, click the X in the top right corner. If you'd like to replace your model with a newer version, click on Replace Geometry, and then select the file you'd like to use. After you've made the necessary adjustments to your geometry, go over to the Mesh tab. Here, you can adjust the mesh using the Mesh Resolution slider. The size of the mesh will determine how many nodes will be created on the model. A higher mesh size will have more nodes and will be more accurate. You can make additional adjustments using these settings down here, but we will be using the automatically generated settings for this tutorial. Once you have made the necessary adjustments, you can click on Generate Mesh. Once the mesh has been generated, you can then go over to the Physics tab. This is where we'll be able to simulate our environment. Start by going over to Material Assignments. Make sure that the material selected is structural steel. Then, using body selection, select the rails and the linear guides, and then swap those out for the existing selection. Click on the back button to go back to the main Physics tab. Then, under Material Assignments, add aluminum alloy. Then, once again using body selection, select all the plates. Then, add those to the selection. Click the back button. Now, under Structural Conditions, add Support. Because our model is not free floating, it will need to be supported somewhere. Using Face Selection, select the bottom of the plate, and then add that to the selection. Once again, under Structural Conditions, add Inertia Load. Under the Y component, set it as negative 9.81. This will serve as the stress due to gravity. Now, click the back button, and finally, under Structural Conditions, add Moment. Using Face Selection, select the front mounting plate, add that to the selection. Under Define By, select Directional Component, and set the X value as negative 9.81. This is an approximation of the moment that would occur if a 10 kg mass was mounted 10 centimeters from the plate. Now, click on the back button, and then click on Solve Physics. Once the physics has been solved, you can then go over to the Results tab. Right-click, go to Add, Results, Equivalent Stress, then, using Body Selection, select the 4 linear guides. This will help us evaluate if the linear guides will fail. Then, click on the back button, and click on Evaluate Results. The maximum displacement magnitude is 1.61 times 10 to the negative 5 meters, which is very small. The half machine confirms its precision. The average equivalent stress of the machine is 7.46 times 10 to the 4th pascals, and this is also backed up by the half model. The maximum equivalent internal stress on the linear guides is 3.71 times 10 to the 6th pascals, which is well within their safe operating range. This was determined by referencing the part specification document for the bearing block.